Good morning, kids. Today we're going to learn about metal.
Oh, you mean...
No, not that metal. Metal alloys.
Well, that's fine too, I guess.
I assume your first question must be, Stephen and Colin, you handsome devils, what are these alloys of which you speak?
I'm glad you asked, audience. Alloys are the result of interference with metallic bonding, which constitutes the electrostatic force between conduction electrons.
The positive metal cations are connected in a lattice formation attracted by a sea of free-moving electrons. Other metal cations fill in gaps of the lattice creating alloys.
Common metal alloys include, but are not limited to, steel, made from iron and carbon, brass, made from copper and zinc, and bronze, made from copper and tin.
Metallic bonding involves any metal that is not group 1 or 2. Alloys consist of metal that is involved in metallic bonding and another metal.
But Stephen, that's a lot of info you're putting down. How can we be so sure this is all authentic?
Always putting a damper on my mood, aren't you, Colin? Well, fine. Let's educate our audience on a brief history of the subject, shall we?
I thought you'd never ask. So, it was known from previous knowledge of electrochemistry that metals dissolve in solutions as positively charged ions.
Previous knowledge of quantum mechanics explains how the sea of electrons exists between metal ions, which is known as the free electron model.
Thermal analysis and X-ray diffraction help us study the crystalline structure of the lattice formation.
Hume Rothery attempted to explain why certain intermetallic alloys with certain compositions would form, while others would not.
His initial attempts were to add electrons to inflate the spherical Fermi balloon inside the Brillouin boxes until they were full.
That sounds like a lot of hogwash to me.
Shh, Stephen, I'm educating. The introduction of cyclotron resonance proved the free electron model insufficient.
But no other model to this date has accounted for these discrepancies.
So the free electron model is still taught in schools today.
Until the chemistry messiah comes to enlighten us.
Fantastic. So, what can you tell everyone about metallic bonding properties?
Metallic bonding consists of high-strength bonds. The metals become ductile, and they are good conductors of thermal and electrical energy.
They're also quite lustrous.
Oh, lustrous, you say.
School appropriate, Stephen, school appropriate.
I just couldn't contain myself.
Now moving on to polarity.
Yes. Polarity. Funny you mentioned polarity.
Why is that?
The compound's polarity depends on whether a dipole moment occurs. If it occurs, the compound is polar.
I feel so much more knowledgeable on alloys.
That's all, folks. We hope you've enjoyed the show.
Bye.